The Avenger-class mine countermeasure vessels are among the smallest in the US Navy battle fleet, but their size belies their importance. They embody the mid to late Cold War focus of the US Navy on securing vital maritime routes against the persistent threat of naval mines. Designed and built between 1987 and 1994, the class was intended to provide dedicated ocean-going mine detection and mine neutralization capabilities. 14 ships were completed, and although a small number remain in service, most have been decommissioned, with the last units recently withdrawn from forward deployments in the Persian Gulf. The Avenger-class ships were conceived to ensure the transit of shipping in littoral environments, particularly in strategically critical choke points such as the Strait of Hormuz and the Miyako Strait near Okinawa. The development of the Avenger class arose from lessons learned during previous conflicts. The Iran-Iraq War in the 1980s and the US-led operations during Desert Storm highlighted the vulnerability of modern navies to mine warfare. Mines, comparatively inexpensive but potentially devastating, could threaten high-value naval assets, from surface combatants to logistics vessels. The USS Princeton, a Ticonderoga-class cruiser, was hit by 2 Iraqi influence mines in the Persian Gulf in February 1991 and had to undergo repair. To fill the mine warfare gap, the Navy pursued a program to build a specialized fleet of mine countermeasure vessels that would combine minesweeping with modern detection technologies. Avenger-class ships were designed to locate, classify, and destroy both moored and bottom-laid mines, providing a solution for the Navy's enduring mine warfare problem. General characteristics of the Avenger class reflect a small design optimized for navigation in minefields rather than maximizing capabilities. Each ship displaces 1,312 tons, measures 68 meters in length, with a beam of 12 meters, and has a shallow draft of 4.6 meters. The relatively small size and shallow draft enhance the ship's ability to operate in littoral areas where naval mine threats are most prevalent. Propulsion consists of 4 diesel engines, each producing 450 kilowatts, supplemented by 2 electric propulsion motors and an omni-thruster bow water jet rated at 260 kilowatts. This combination allows a cruising speed of approximately 14 knots, suitable for the slow and deliberate maneuvers necessary during mine hunting operations. The complement is modest, comprising 8 officers and 76 enlisted personnel, and armament is minimal, with 4 50-caliber machine guns and mine neutralization systems. The whole design of the Avenger class is one of its most distinctive and purposeful features. Constructed primarily of wood, including oak, Douglas fir, and cypress coated with fiberglass, the wooden hull provides flexibility against nearby mine detonations while minimizing the ship's magnetic signature. Mines designed to detect large metallic targets are less likely to respond to such a low-signature platform made of wood, increasing the ship's survivability in mined waters. This approach reflects a design philosophy that prioritizes mission-specific effectiveness and mission-specific survivability over multi-role versatility and general survivability. Sensor systems aboard the Avenger-class ships are specifically tailored for mine detection and classification. The AN-SQQ-32 mine hunting and classification sonar, developed by Raytheon and Thales Underwater Systems, employs a geo-sonar configuration mounted in a small submersible pod that can be towed beneath the ship. The sonar system combines a high-resolution classification sonar with a search and detection sonar, allowing the crew to locate and identify mines both on the seabed and moored near the surface. When not in use, the pod is housed in a below-deck trunk, streamlining ship operations. Navigation and surface search are supported by AN/SPS series radars, including the AN/SPS 55 and later AN/SPS 73, providing situational awareness. These systems, while highly capable at the time of introduction, rely on traditional, operator-intensive procedures and limited automation compared with modern digital systems. Mine countermeasure systems aboard the Avenger class are comprehensive for their era. The ships employ AN/SLQ-48 remotely operated mine disposal vehicles, as well as the EX-116 Mod 0 remotely operated vehicles. These vehicles are tethered to the ship via long cables, allowing precise manipulation of neutralization charges and cutters to disable mines safely or destroy them. Each remotely operated vehicle is equipped with high-frequency sonar, low-light cameras, cable cutters, and explosive charges, offering a multifaceted approach to mine clearance. The ships can also deploy traditional towed mine-sweeping gear designed to mimic the acoustic and magnetic signatures of larger vessels, triggering certain types of mines without sustaining damage. Collectively, these systems provide a high level of operational capability, but require the ship to remain within the minefield itself, exposing the vessel to risk. Despite the Avenger class's capabilities, it is increasingly clear that these ships are becoming outdated relative to the most advanced mine countermeasure platforms fielded by both allied and potential adversary navies. Japan's Maritime Self-Defense Force, for example, has developed the Awaji-class mine countermeasure ships, which integrates fiber-reinforced plastic hulls for magnetic signature reduction, coupled with advanced autonomous systems. These ships employ variable depth sonar, LiDAR, and unmanned underwater vehicles to detect, classify, and neutralize mines with a level of automation and standoff distance that Avenger-class ships cannot match. Similarly, the People's Liberation Army Navy of China has dramatically expanded its mine countermeasure capability over the past 2 decades with numerous new vessels, incorporating remotely operated and autonomous mine hunting systems into a growing fleet. The most capable Chinese minesweepers include the Type 082, the Wozang class, that can deploy remotely operated vehicles to hunt mines, and can even remotely operate up to 3 uncrewed minesweeping boats. There's also the Type 081, the Wochi class, intended for larger-scale minesweeping, using more conventional methods. The PLA Navy's mine-sweeping capability is more confined to the littoral waters, to the first island chain, but their combination of quantity, modernization, and automation surpasses the legacy capabilities of the Avenger class. In addition, the Royal Navy's Hunt-class minesweepers, though contemporaries of the Avenger class, have also undergone incremental modernization and employ remotely deployed systems like the Sea Fox, reflecting a wider international trend towards unmanned, networked mine clearance operations. By contrast, the Avenger class relies heavily on manual control and operator skill, and each mission is inherently slower and riskier due to the requirements for the ship to operate within the mined area. Automation, integration of unmanned systems, and networked command and control represents the defining features of the most advanced mine countermeasure vessels today. These are areas where the Avenger class design is limited by age, hull configuration, and sensor obsolescence. The obsolescence of the Avenger class has practical consequences for the US Navy. With the gradual retirement of these vessels, there is a clear gap in dedicated mine countermeasure capability, particularly in littoral regions where naval mines pose a persistent strategic threat. Modern adversaries can deploy mines with precision, at low cost, and in ways that threaten both surface action groups and logistics supply lines. As a result, the Navy has turned to the littoral combat ship program, particularly the Independence-class variant, to fill this capability gap. The Independence-class LCS is not a dedicated minesweeper, but was designed with a modular mission bay capable of accommodating a range of mission packages, including mine countermeasure modules. The trimaran hull of the small LCS offers high speed, stability, and a shallow draft suitable for littoral operations. Its mission bay can house unmanned surface vehicles, unmanned underwater vehicles, and airborne sensors, all coordinated through an integrated combat system. These unmanned platforms allow the LCS to hunt mines at standoff distances, dramatically reducing risk to crew members. Multiple vehicles can be deployed simultaneously, providing a level of coverage and operational tempo that legacy Avenger-class vessels cannot achieve. However, the LCS is not a silver bullet. It is obviously a very troubled class of ships. Structural vulnerabilities, propulsion problems, limited defensive armament, and reliance on larger escorts such as Arleigh-Burke destroyers are just some of the more troubling examples of these issues. Nevertheless, the mine countermeasure role aligns with the inherent strengths of the Independence-class design. In this niche, the LCS has real utility, enabling the Navy to maintain mine clearance capability while planning for a future dedicated replacement. The Avenger-class mine countermeasure ships were a highly capable and purpose-built solution when introduced, combining innovative wooden hull design, operator-driven sonar systems, and remotely controlled neutralization vehicles to address the persistent threat of naval mines. Their wooden and fiberglass hulls and mine-hunting vehicles allow them to operate in dangerous areas that would threaten conventional metal-hulled warships. Yet, technological evolution and changing operational doctrines have rendered these ships increasingly obsolete. Modern mine warfare emphasizes autonomous systems, robust networks of unmanned platforms and sensors, standoff capability for mine sweeping, and reduced risk to personnel, all areas in which the Avenger class is limited. In contrast, Allied navies, including Japan and the United Kingdom, have fielded platforms that reflect these advances, and so has China's People's Liberation Army Navy on an even greater scale. As the Avenger-class fleet gradually retires, the US Navy is relying on the littoral combat ship, equipped with its dedicated mine countermeasure mission package, to maintain capability in littoral regions and critical choke points. Whether there will be enough to fill the shoes of the Avenger, we will see. The story of the Avenger class illustrates the balance between maintaining specialized legacy platforms because of their indispensable capabilities and the slow-burning pressure to replace these platforms with better ones. As the US Navy tackles the enduring challenge of keeping pace with rapidly evolving mine threats and mine countermeasure technology